Cool, kia ora everyone, thanks for having me. My name's Jenny and I'm talking about the machine count. So senior data, I call myself generalist because I feel like data scientist has been like co-opted by the machine learning engineers and I really don't do any AI, but yeah, data scientist, data journalist. And project lead at Rewiring Aotearoa, which is a climate data non-profit here in New Zealand. I was previously at Xero and then at Multitudes, a New Zealand tech startup that actually just operates out of Grid Upstairs, where I met Emily and learned everything I know about data engineering from her. Did some talks during that time. That's Kiwi PyCon, New Zealand Tech Rally. But outside of work, I was getting really involved in climate activism. So that photo there is from the September 2019 climate protest. That was the one, the big one, where we had 50,000 people walking down Lambton Quay, convinced 50 people from Xero office to come to support all the students to push for more climate action, did some non-partisan-y work for climate stuff, and then founded a climate non-profit called Climate Club Aotearoa, little plug. And we put out like a weekly newsletter that helps people distill all the high impact actions around climate around the country. And then we also run some events, including one that happened right here last year. So in amongst all that, I was working in tech, I was volunteering for the climate movement. And then I came across this news article, which said that Kiwi households could save thousands if they electrify their cars and homes. And so this guy, this Central Otago cherry farmer, was saying we can save money while reducing emissions, backed up by a whole lot of data that looked very interesting. So I just cold emailed him and said, hey, do you want like a data climate person? And that's how I joined Rewiring. So part one, machine count. Why count machines? So I'll dive into a bit of background because this was a big learning curve for me when I realised, I'm like leaving the tech centre and entering the energy sector. So I'll try to do a really brief overview. So 73% of global emissions are from energy use. Energy use basically means fossil fuels that are burnt in machines. Machines like cars, heaters, cooktops, motorbikes, lawnmowers. So for New Zealand, about 30% of our domestic energy use is 30% of New Zealand emissions are from domestic energy use. So that's, again, fossil fuels burnt in all our cars and our lawnmowers and heaters. And so if you look at this little household, not very little, this household emissions section here, so that's 25% of New Zealand's gross emissions coming from household domestic energy use. That's all the water heaters, space heaters, cooktops, cars, chainsaws, you name it. So these are dinner table decisions that everyday people are making, and that makes up 25% of our domestic emissions, of our gross emissions. And that sort of flips the script a little, where you sort of think, the climate emissions reduction stuff is this policy thing that happens over there with the Ministry of Transport and the Ministry of Business, Innovation and Employment and this other one. But actually, quite a lot of our emissions are really easy purchase decisions that everyday people like you and me make every day. So if we look at our energy system, we really pride ourselves on this really renewable grid that we have, but we have to remember that the grid is only electricity and a lot of machines don't actually run on electricity. In fact, 67% of our energy use in the last 5 years has been from fossil fuels. If you think of all the trucks, the cars, the tractors, the barbecues, they don't run on electricity yet. And that amounts to about $40 million per year, per day, or $15 billion per year leaving the economy in the form of fossil fuel imports from overseas. And, we're not even going into all the costs of all those distribution ships, the trucks on the roads, the impact of that on our economy, on our country. Just imagine what we could do with an extra $15 billion per year in our economy, like healthcare, education, literally anything else other than paying fossil fuel corporates. Like it's just an astounding number. And so a lot of the research we did early on about this time last year was around what is it around the home that we can electrify. And we identified 6 key machines: cars, space heaters, so that's just the thing that keeps you warm, stovetops, replace it with induction, space heaters, replace with heat pump, water heaters, you can use resistive electric or water heater heat pumps, which are like massively efficient, but they're kind of new, so people don't really know about them. Get rooftop solar, which is the most cheap form of electricity ever known to mankind, and a battery so you can ride the peaks and troughs of the grid and explore when the price is high. So that's so we know about all these machines, but why count them? And so the reasoning for that is that when you look at emissions from a machine level, it helps identify the low-hanging fruit for early emissions reduction. So climate change is a cumulative problem. So if you eliminate one petrol car today, those potential petrol emissions have been eliminated for the lifetime of that car. So electrifying one petrol car today is far, far better than doing the same thing 15 years from now, because during those 15 years it would have kept emitting for that whole time. And so we want to identify which ones are the machines that we can electrify immediately, and we want to go really hard on those to buy us time to work on the harder to electrify machines. It also really laser focuses us on the individual dinner table purchases behind our fossil fuel demand. When you look at our emissions profile, it's kind of overwhelming to think like, oh, big numbers, big megatons, CO2 equivalents. But if you break it down to what are the machines that actually make up that demand, we can see what our actual practical emissions reduction pathway could look like. And you realise it's a step. For every house, it's a step function. It's not this linear thing that magically happens over time. Every time you decide to renovate your kitchen or to replace your car, that's a massive permanent reduction in your household's emissions. Understanding the actual quantity, the function, so how they're used, the energy needs, the capital cost of buying a new one, and the operating cost of operating each of these machines allows us to develop granular, targeted policies. And then also sheds light on the learning rates of electric technology. So if you're focusing on what the actual machines are, or what the actual fossil fuel machines are, and how we can replace them with electric alternatives, you can start to prepare for market changes. So for example, these are the learning rates, as in the costs dropping over time, of the Ford Model T, the first car on the market, alongside the cost of solar over time. And it's pretty precipitous how quickly the price is dropping. Solar is obviously a bit of an overarching technology because it generates electricity which can power other machines, but it's just an example of how, similar things are happening for EVs. Like the price of EVs has dropped massively, even since 2023. If we weren't focused on the machine level, we would miss these sorts of market opportunities that companies, businesses, the government, communities, councils can look at, prepare for, make sure everything is in place, all the charging infrastructure, all the accessible financing, whatever is needed to help New Zealanders adopt these opportunities as fast as possible. And lastly, focusing on machines shows the impact of committed emissions. So this is the emissions that you commit to from purchasing a particular machine. So let's say you buy a hybrid vehicle. So hybrids, on average, still emit about 70% of the emissions of a petrol car because, they're not actually they don't actually save that much petrol. So if you buy a hybrid car today, your operating emissions drop by 30% immediately. But what you don't see is that you're going to be operating at 70% petrol emissions for the next 15 years or however long you hold on to that car. And so if everyone bought a hybrid today, our annual emissions for this year would drop by 30%, and that would look amazing. But what we don't realise from that purchase decision is that in 15 years from now, 2040, our emissions will be the same because everyone's still driving their 15-year-old hybrid car, unless everyone decides to scrap it early, which would be a pretty tough call to make. And we wouldn't have actually made progress on our emissions. So yeah, the committed emissions become much clearer when you look at things from a machine perspective. Okay, I need to go faster. So that's why we're creating New Zealand's first inventory of fossil fuel machines. The requirements for the project were that it's publicly accessible and easy for non-tech people to use. The source data that we're going to pull from to get the counts and all the other metadata about it were things like government CSVs, government reports, OIAs, surveys, and then also manually input data from our own desk research. We're talking hundreds to thousands of rows, so not huge. So I originally thought it was going to be like every machine, like one row per machine, but actually that was a bit of a data engineering thinking style of approaching it, and actually it was more what the outcome that we wanted was like one row per machine type. So it's like car, 3 million, barbecues, 1 million. And there was going to be lots of metadata alongside each of these numbers. So we wanted to be really stringent about how we justify all our numbers. So we wanted to have a lot of space for free text to say like, oh, this number was pulled from this report in 2023, but then we also added this consideration from this other report. So the early exploration that we did for figuring out what a good tech stack might be for this database was I just jumped to traditional data pipeline because I'm a data person, And so I just thought, oh yeah, cool, like I got it. So I'll just put the CSVs in something like Google Drive or S3, and then probably locally, because it's really small, just do like some sort of, ETL thing, and then chuck it in a data sync, which will probably also be something simple like Google Drive or S3, especially because it needs to be like non-tech accessible, and then put like a visualization layer over it, like a dashboard, Streamlit, Shiny, and then it can be accessible to the public. Great. And so I sort of went on a bit of an early deep dive on frameworks and tools I could use. Requirements were that it's free and open source because we're a non-profit, and budget is a thing. And ideally everything can be versioned as code. So things that we didn't need high throughput or async capabilities. It is static data. We're collecting things from government reports that update quarterly or every year. So we're not, ingesting live streams or anything. Don't need Kafka or streams or anything like that. Not a huge use case for efficient data storage because we're talking hundreds to thousands of rows, less than 50 columns. Don't need parallel distributed, don't need machine learning. Most of our models that would sit on top of this data are like analytical economic models. So I had a look at I was thinking about data orchestrators. I think this was around the time the first Mage workshop happened, so I was like, orchestrators. So pros, you get cool error handling, strong type validation, very important because very many disparate data sources, and it really promotes good testing of the data transforms. Because I was thinking like, if we ingest some survey data, I want to transform that into our perfect machine count schema and then put it in the database automatically. Things that we probably won't be using, so don't really care about, is scheduling and triggering. Again, not real-time data, so manual reruns. Monitoring, again, manual triggering, and short run time, so you're probably going to know immediately if something broke or is breaking. Scaling and parallelism, don't need that either, very small data set. And then cons, it's a pretty intense thing to be introducing to a project when we're talking like hundreds / thousands of rows. And especially when, crucially, I'm not in a tech company anymore. I'm in a non-profit where I'm one of very few data people and very few people who can code, so that had to be a consideration. But did a quick pros and cons. I won't read through everything, but had a quick Google round. Ended up thinking if we were to get an orchestrator, we'd probably use Dagster or Mage, just because they seem to have really nice Python APIs, good type safety, and a few interesting, just really cool tech that people seem to be really enjoying in the data engineering community. So those are the ones I landed on. But in the end, went with plain Python because the data was so small and there were no complex scheduling needs, so felt kind of overkill. But was good to have in mind that if we decide to scale it in the future, or if some really interesting sort of real-timey or automated data sources from the government or wherever else about fossil fuel machines became available, we could use Dagster or Mage. Wanted good type validation. We knew we'd be using Panda, so Pandera was kind of the obvious choice. Looked into like MyPy and Marshmallow and Great Expectations a little bit, but just that was sort of what we landed on. And the ETL, again, plain Python. It's not a big deal. It's pretty chill. So wanted to keep it small. Having said all that though, I think we got to this phase, and this was very useful for processing a lot of the survey data that we were ingesting. But we did find that more and more, a lot of the estimates of counts and the energy use and things like that were coming from desk research. And so this is reading, 200-page Ministry for the Environment reports, pulling out like numbers in the middle of paragraphs. You could say something about LLMs here, but like that was not where we're at. And so I had another look at our requirements, and I thought, okay, it needs to be easy for non-tech people to use. And to be honest, the whole thing that I'd dreamed up there wasn't that easy. Like it's still a CSV in Google Drive, and if someone downloads that and puts it on a Google Sheets or something, it's like usable, yes, but it's not like presenting things in an interactive way at that stage. Also, a lot of the data ended up being the manually input data. So someone's reading through a report, picking out that this particular boiler in Huntley is emitting this much, and then having to manually enter it. So something that non-tech people could easily enter without me building like an entire input form was important. And then also the metadata and notes, sources and justifications, that was pretty key. And whichever way you look at it, CSVs aren't great, or any sort of database is not really great for having big paragraphs of writing in it. and especially not easy to edit and to talk about and to add comments on and collaborate on. So I was here, basically, and yes, so I just ended up going, to Google Sheets. So yes, we ended up using Google Sheets, but I did try to incorporate as many data engineering principles as I could into that spreadsheet design. So firstly, data validation everywhere. So this is like the final-ish database. And you'll see everything is a drop-down, everything. Like there was no exception. In fact, there was no exception, I think. I was very strict about this, and it means that if later on we export it to a CSV and we want to do some data analysis on it, we can do that. And you can do a nice value counts on your pandas table and it will work. So there was that. So everything is mapped to a key. So this is like the key sheet, and then the data validations, reference that range. And then you can see the definitions. Cell references everywhere, so nothing is hard-coded in. So for example, all our emissions, so when we did all the OPEX and emissions calculations for each machine type, we were referencing a separate table which had all the emissions factors and fuel densities and energy prices. And so if, let's say, the government released a Q4 2024 update on energy prices, we can just change the price of petrol and it will update everywhere. Lots of cell formulas. You can do some pretty intense things in Google Sheets, I learned. So everything was as codey as possible to make it sort of scalable and maintainable. No merge cells, pretty basic but pretty key. And there were some places where it was very tempting to merge some cells, as you can see, region, sources and notes, region, count confidence, region, link to supporting analysis. And I was so close to just being like, merge, region. But no merge cells. Because if you export it to a CSV, you want every cell to have a value in it. And then lastly, we had a single source of truth for all machine types and then matched it everywhere else based on a generated ID so that every sheet would reference the same machine types. I'll just illustrate. So this was our machine categories source of truth table. We separated it into various category levels, so all the air transport, the common name, a plane, a hot air balloon, a variant, a big plane, a small plane, and then extra variants and things. And these were all sort of combined into a string ID, a unique string ID. And we use that for all the other sheets. So this is the counts table. These columns are usually hidden, but you can pick from a drop-down, from a data validated drop-down, the ID, and then it'll auto-populate the name. So if you're entering the number of cars, you're not entering car and then the number. You're selecting the car's ID, and that auto-populates the name, and then you add the count. Same with our electrifiability sheet. So here it's talking about how easy is it to electrify, again, the ID. Our electric alternative models sheet, again, the ID is used, and then we use an index match thing. So those were the sort of data engineering principles I was using to design the spreadsheet so that it could be scalable and maintainable for the future. And so the exciting part, the results, the majority of fossil fuel machines are ready to electrify today. Woo! So this is the quantity, not the emissions. I will show you the emissions soon. But 84% of the fossil fuel machines in New Zealand, so 8.6 million of them, are ready to electrify. So that means they are mainstream available in New Zealand, and they are cost competitive or better over their lifetime. So you will save money or even out, break even, over the lifetime of those machines. If you break them down into what they are, we've highlighted some interesting ones. So cars is top of the list. There we have 3.5 million cars in the country. This is light and medium vehicles, not including utes and vans and things, which you can see further down. EVs are pretty mainstream. They will absolutely save you money in the long run. Actually, the payback period is shorter and shorter every year. The embodied emissions of the batteries and all the rest of it in the manufacture is vastly outweighed by the emissions you save from the petrol and diesel you don't spend. It's just a no-brainer. So the tricky part is the upfront cost, which I'll get to later. Space heaters is the next big chunk. These are all the gas heaters, the LPG heaters, coal burners, that's still a thing, wood fires, so that sort of thing. And you can replace that with a heat pump, which is massively efficient and costs way less to run. Cooktops, motorbikes, mowers, barbecues, etc. The almost ready machines are the ones that are available in New Zealand, and they are also cost competitive, but they're not quite so easy to just buy off the shelf. And so they're ones that might require a bit of special procurement. Maybe you need to do like a import with the manufacturer from overseas. Those are the ones for which we need focused policy intervention, because we could decarbonise these tomorrow. It's just they're not available in the New Zealand market right now. And so these are things like heavy trucks, utes, which I think there's a Ford Ranger and the other one, and a Toyota Hilux coming out this year, but it's only in America. So it's these kinds of things, lots of light vans, but not all vans, not all sizes of vans have an electric alternative. We have lots of electric buses around, but they're still not what I'd call like off-the-shelf purchases, medium trucks, that sort of thing. And the last category, not ready, these are the ones where it's either not technically feasible yet, like there isn't a commercialised electric alternative available, or it's not cost competitive, so there is an electric alternative, but it would cost you more in the long run because it's still quite new. And those are things like electric boats, electric big tractors, excavators, planes, that kind of thing. And this lovely chart, which Divya made, nice, shows the potential emissions reduction from electrifying those machines. And so we took the top priority machines from an emissions standpoint for each of those three categories, and then did the full emissions calculations for them, taking into account the average emissions per machine times the count of the machine. Cars is the biggest chunk, then space heater, water heater. In the almost ready section, there's the heavy trucks and the utes, and then the not ready, there's the heavy vans, tractors, and then the big one at the end there is industry emissions like process heating. These are like the big boilers and things, which do require a bit of technological innovation and process change, and and then the rest of them. So you can see if this is our total emissions per year, and we can get to pretty much, we can halve our emissions from machines by just doing these top priority machines from each of these categories. That's pretty great and something that we should definitely do as soon as possible. So that's been a really cool finding. And in terms of the total impact of those top priority machines, so this is not all the machines, but just the top priority ones, that would save $7.9 billion a year and 15.8 megatons of CO2 equivalents per year for the country. So now I'll just do like a quick showcase of all the cool electric alternatives that we found in our research. I was going to do EVs because I was like, everyone knows EVs. But actually, in my research, I was so surprised because I was like, oh, there's like the Nissan Leaf. But no, there are so many. There is the GWM Aura, the MG4, the Polestar, the LDV T60 Ute, the Ford Mustang Mach-E, the BYD Atto 3, BYD Seal, what's that one? Hyundai Ioniq, Hyundai Kona, Kia Niro, no, Mercedes-Benz, Kia Niro, which has a 650 kilometre plus range. Like EVs, we're not talking about your 10-year-old Nissan Leaf anymore, which are now $3,000 in Trade Me, by the way. $2,000 or less, in fact. Yeah, you will save money you will pay it back in 1 year. Like you pay more than $3,000 in petrol, like I guarantee it. You can get to Auckland to Wellington with one lunch stop with a fast charge. So yeah, definitely think about that. Other cool electric machines, FT in Motion Street Dogs. I took a test ride on this the other week and it was so dreamy. And it's built in New Zealand, it's built in Hamilton. So these are some pretty cool motorbikes. And the 50k one, you can ride on a car license. So you can, anyone off the street with a car license can just jump on. And there's actually one on Trade Me right now for $8,000 that someone's selling in Wellington, and I really want to buy. But someone else should buy it. Someone else should do that. E-bikes are great. E-bikes have just massively flattened out the hills of Auckland. Obviously lots of e-bikes, secondhand, new, all kinds of models, but this one came out recently, also built in New Zealand, and it's the world's lightest e-bike. So I think it's 12 point something kilos, which is about as light as my road bike, and it's pretty gorgeous. The VSEV V9 hydrofoiling ferry, which is operating right now by Fuller's in Auckland Harbour. The first electric fire truck, Christchurch Airport has just imported one. These Mercedes-Benz rubbish trucks, so I think Waste Management have a few of them, and Waste Management have actually done a great job of retrofitting their existing rubbish trucks to become fully electric. The Connect 55 HP tractor, and the cool thing about electric tractors is that they can do work that is quite a bit higher than their stated horsepower range. So I think it can do the work of about a 70, 80 horsepower diesel tractor because of the instant torque of the electric motor. So especially the PTO, the like attachment thingy, it can drive at much higher loads. This ride-on mower, yeah, this is big. I did like a whole project on farming stuff, and ride-on mowers are huge. And this one is like the biggest of the lot, and it's fully electric. What are these? ATVs, side-by-sides, crucial for farming. Big truck, big range. Commercial induction cooktop, so like cooking with induction. A coffee roaster, which are all gas. I didn't know that, but all coffee roasters run on gas, except a few that are coming out now that are electric. This one's running in a shop in Queenstown, and there's another one at Frank's in Wellington. The Stark Varga, the world's fastest endurance dirt bike, full stop. Like not fast for an electric, fastest. Like faster than all the diesel, all the petrol. It is just the fastest in the world. This electric jet ski, pretty cool. This snow thing, snow groomer, crane, digger, bulldozer, helicopter. Yeah, that's it. So I'll finish off with the key message is, rather than spending all our time and money on the highest hanging fruit when solving climate change, why don't we make existing zero emissions machines affordable and accessible for all New Zealanders, and then we can save heaps of our emissions overnight and buy us time to solve the harder problems while saving New Zealanders money. And then the other takeaway was sometimes it really do be like that, and it got us where we are today. Thank you. You can check us out on these things, and thanks to Aotearoa for funding this project.